Swayam Prabha. Digital India. Educated India.
Hello friends, so welcome to the course Introduction to Sampling Theory. So you can recall that in the last lecture we started a new chapter on the topic of varying probability scheme, and we had developed the concept for PPS, probability proportional to size sampling. And this type of sampling scheme actually is more useful when the sizes of the units are varying a lot. And if you try to see, these sizes are going to be used to compute the probability of selection, and they will also be used in the construction of a new random variable or transforming the old random variable using this probability of selection. And if you try to see, these sizes are going to provide us some sort of weight which we can provide to the individual observation, so that ultimately we get a good estimator, for example having nice statistical properties like unbiasedness, etc. Now once I am talking about the concept of the weight, means if you try to see the structure of the expression of sample mean, the sample mean is written as y1 plus y2 plus up to yn divided by n. Can you write it like y1 upon n plus y2 upon n plus y3 upon n up to yn upon n? So what are you going to do? You have assigned every observation y1, y2, yn a weight 1 upon small n, and this helps you. Can you think, if I don't take small n, but if I take something else, say I take 2 upon n, do you think that you are going to get an unbiased estimator? Not really. So now the next question is this: using these weights we are going to transform our variable of study. But before that we have to draw the sample. Definitely the samples in this case cannot be obtained like as in the case of simple random sampling or stratified sampling, which are based on providing equal weights to all the observations, as I took the example of 1 upon small n, right. And even if you try to look into the procedure of stratified sampling, well, we are trying to stratify it, but ultimately we are using simple random sampling. So now the bigger question is how to draw the samples in probability proportional to size sampling. And you can imagine that when you are trying to draw the samples from this PPS, then you have to be careful, because in case if you try to draw the sample by without a replacement or something like this, then after every draw the probability of the unit will change. So this PP has its own complication when we are trying to draw the random samples. So just like a simple random sampling, in PPS also you can draw the sample by with replacement as well as without replacement, right. So now today we are going to understand this concept. Why I am calling concept? Because whatever methodology you are going to adopt to draw the sample, you have to ensure that the probability of selection of the observation is proportional to the size of the variable. Which variable? Auxiliary variable, capital X. right. So, first I will try to give you the construct, then I will try to explain you the methodology, I will try to show you whether the probability of selection of observation is proportional to the size or not, and finally I will try to take an example by which I can show you that how really you would execute the drawing of sample. Right. Okay, so let us begin this lecture, and if you want to download the slides of this lecture, you can go to my home page where I have uploaded the PDF files of this lecture, and from there you can download it. The address of my home page where I have uploaded the slide is home.iitk.ac.in /shalab/sp. And if you are facing any problem in reaching to this address, then you can also scan this QR code, and you can use any free application on your cell phone to scan this QR code, and this will also bring you to the same address. And if you are facing any problem even after this, then I would request you that you go to any internet search engine, try to give my name, try to search for my name as well as institution, and I am sure that you will find my home page, and from there you can download the slides. So, now we are going to discuss about the methods of the sample selection in varying probability scheme. So, particularly we are now going to concentrate on PPS sampling, that is the probability proportional to size sampling. Right. So, in PPS sampling there are two possibilities to draw the sample. Just like in the case of simple random sampling, we have with replacement and without replacement. So, when we are trying to draw the sample by with replacement, we indicate it by PPSWR, and when we are trying to do it by without replacement, then we try to do it with PPSWOR. So, just like we have in the case of simple random sampling SRS and SRSWR, WOR, similarly we have here PPS, PPSWR and PPSWOR. Right. Now, what will be the difference between the two methods of drawing the sample, with replacement and without replacement? When we are trying to consider the selection of units with replacement, then in this case the probability of selection of a unit will not change, and the probability of selecting a specified unit will remain the same at any stage. There is no redistribution of the probabilities after a draw. Why? That is very easy and natural to understand, that you have got some number of sampling units in your population, you are trying to draw the sample, and every sampling unit in the population will have a different probability of selection, something like P1, P2, Pn and so on. But once you are drawing a unit and then after that you are putting it back in the population become the same, the probabilities will again become the same, right. But this will not be the case when we are trying to do with the without replacement. In the case of without replacement, every time you draw a unit and you are not going to keep it back in the population, so all the values of those probabilities will be changing after every draw, and those values of probabilities will have to be determined after each and every draw, right. So, in the case of selection of unit without replacement, the probability of selection of a unit will change at any stage, and the probabilities are redistributed after each draw. So, now you can imagine that in the case of PPSWOR, once you draw a unit, after that you have to recalculate all the probabilities, whereas this is not the story in the case of PPSWR. And once you have to do this thing, you can imagine that drawing the sample by PPS PPS WOR without replacement is going to be more complex than PPS with replacement WR. Right. And possibly you never thought when you were trying to do simple random sampling and other things, you were simply drawing the units one by one, that is all. So, now in the beginning itself, now you have some idea that what type of issues you going to face, which you have not faced in the case of simple random sampling. Right, but anyway, we are going to consider both the cases one by one separately, WR as well as WOR. Well, definitely this PPS WR is easier. So, so we try to first understand easier part. So, now the question comes how one can draw the sampling unit from the population using this PPS sampling. Right. So, for that we are going to discuss here two types of methods. One is cumulative total method and another is Lahiri's method. Right. We will take up one by one. We will try to understand their procedure. We will try to show that the probabilities of selection of the units in each of the method is proportional to the size, and then we will try to take an example also where I can illustrate you that how are you going to compute it. Right. So, in the case of cumulative total method, which is used to draw the samples by PPS WR, here we have to collect a sample of size n. Right. Then this procedure consists of associating the natural numbers 1 to capital N to the units in the population. That means, whatever are the units, you assign them number 1, 2, 3, 4 up to say capital N. If there are 100 units, you try to assign the number 1, 2, 3, 4 up to 100, and if there are 500 units, you try to assign the numbers 1, 2, 3, 4 up to 500. And then we would like to collect those small n number of units whose serial number corresponds to a set of n numbers where each number is less than or equal to capital N. And these numbers, they have been drawn from a random number table. Well, what does this mean? Means in the first shot you may not be feeling comfortable, but try to read it, and then once I show you that how you are going to execute it, it will become very simple. Its methodology is very simple. So, we are first associating the natural numbers 1 to n to all the units in the population, and then we are choosing small n numbers of numbers from the random number table, and then corresponding to them we are trying to choose the corresponding numbers from the population according to a specified way. What is that way? That we are now going to, I will try to show you. So, in the selection of such a sample with the varying probabilities, the procedure is to associate with each unit a set of consecutive natural numbers, and the size of the set being proportional to the desired probability. Do not worry, that is a very simple thing. Believe me, as soon as I show you the procedure, all this statement will become very easy for you to understand. Right. So, if I say that suppose x1, x2, x capital N are the positive integers proportional to the probabilities, and they are assigned to the capital N units in the population. Then one possible way is that we associate the cumulative totals of the units, and then the units are selected based on the values of the cumulative totals. Right. For example, I will try to show you this procedure in this following table. Suppose I have got here units in the first column, say here 1, 2 up to here capital N, and yes, somewhere there is going to be a unit say I minus 1 and I. Now, corresponding to this, they will have some size. Suppose if I say there are suppose 20 plots. So, I try to give them number 1, 2, 3, 4 up to 20, and suppose I say the area under the cultivation or the size of the plot is my size variable, say xi. So, now I will try to write down the area of those plots. Plot number say here 1, it has area x1, plot number 2, it has area x2 and so on. So, that is pretty simple thing. So, corresponding to every unit there will be a variable size, right, corresponding to all the units in the population. That is what it is trying to show you here by this capital N. Now, you have here x1, x2, xi minus 1, xi up to here capital Xn. Now, corresponding to these sizes, we can find out their cumulative totals. Right. What do we really mean by cumulative totals? If I have suppose here some numbers 10, 5, say here 15, then the first total will be 10, the second total will be the sum of first two totals 10 plus 5, and third cumulative total will be sum of all the numbers preceding to it. So, that will become 10 plus 5 plus 15, right. Okay. So, now if you try to see, now this is my first observation corresponding to you have the cumulative total of the sizes. So, we call them as cumulative sizes, say, and we are trying to denote it by the number T1. T1 is equal to capital X1. Now, this T2 will be the cumulative total of the first two units, that will become X1 plus X2. And similarly, if you try to write down here Ti minus 1, so that will be, that is going to be the sum of all the units up to Xi minus 1. So, j will become here 1 to I minus 1 and xj, and similarly here Ti will be the sum of all the units up to xi. And similarly, if you try to write down at the end capital Tn, so capital Tn is going to be the sum of all the units, right. So, now you have here numbers, say here up to here given T2 Tn. So, now what you have to do here, you have to select a random number, say r, between 1 and Tn, and this number has to be selected from the random number tables. Once you have selected the random number, then now you have to take a call. In case if this r, this is lying between Ti minus 1 and Ti, means somewhere here, then I would say ith unit is selected. If r is there, that means this unit is selected, the unit below it, right. So, this Ti corresponding to this xi. So, now this xi will be coming to your sample, that will be joining to your sample, and the probability of selecting such a unit is given by xi upon Tn, that is xi upon sum of all xi's, j goes from 1 to n, right. So, this I will try to show you mathematically also. At this moment you can just take this probability statement, and now by this you will add one unit to your sample. Now, in case if you want to add a small n number of units in your sample, you simply have to repeat this procedure small n times. Just keep on choosing the random numbers and then try to see in which interval the random number is lying, and corresponding to that you try to choose your xi, right. The first question comes in any of this random selection procedures in this varying probability scheme, that the number which you are going to draw, suppose you have chosen r and then you have chosen xi, What is the probability of selection of this number or this unit? As we have discussed, the basic fundamentals says that this probability has to be proportional to the size of the unit, and we have associated the variable x with the size. Right. So, now in this case, in this cumulative total method, if you try to see, the probability of selection of ith unit is Pi, which is actually Ti minus 1 upon Tn. Right. That is the probability, because if you try to see, you are simply trying to see whether this number is lying between Tin and Ti minus 1 or not. So, and what is this Ti minus 1? Means if you want to write down here, j goes from here 1 to I, xi minus j goes from 1 to I minus 1 xi upon here Tn. So, this is going to be simply here you are trying to cancel all the units up to I minus 1. So, finally, you will have only here xi. So, this is here xi. And what about this Tn? Tn is the sum of all the xi's. So, that is going to be fixed. So, obviously, this Pi is proportional to capital Xi. Right. So, you can see here that the way you have drawn the random numbers using this cumulative total method, the probabilities of selection of these units is proportional to the size xi. So, remember one thing, capital Pi, which we are indicating, that is the probability of selection of the unit, and xi is the size of the auxiliary variable, which is being used to get the information on the size. Now, what is the drawback of this method? Actually, in this procedure, you can see here that we have to write down the successive cumulative totals, and this is time consuming and tedious if the number of units in the population is large. Well, this concept and this methodology was not proposed yesterday or day before yesterday. Now, you are in the age of computers, so computing such cumulative totals is not very difficult, right? That is a very simple job. But when this method was evolved, at that time there were no computers. So, yeah, writing down all the cumulative totals, etc., that was not an easy job. Means if you have suppose, even if I say that you have suppose 1 million observations, and you have to write down all the cumulative totals, you can imagine that how much time will it take. So, from that point of view, I am trying to write down this drawback, because nowadays nobody can say that this is really a big drawback if somebody has to write down the cumulative totals of 1 million numbers, right. But anyway, this problem is overcome in the next method that we are going to discuss, which is Lahiri's method. So, in the Lahiri's method, what we do, that we try to choose a number capital M, which is the maximum of these sizes. You have those sizes, you can see here, you have here these sizes x1, x2, xn. So, whatever is the maximum size, you try to choose here, right. And this can also be some convenient number which is greater than capital M size. So, essentially you have to first fix capital M, which is the maximum of the sizes of the capital N units in the population, or some convenient number greater than M. Now, the selection procedure of a number using this Lahiri methods involve that you had that instead of choosing one number, you have to choose two numbers from the random number table, right. So, the first step is that try to select a pair of random variables, say ij. I comma j, such that I is lying between 1 and capital N and j is lying between 1 and capital M. What is the difference? Small I, this is a number, integer, because you are going to assign every unit an integer. So, if there are capital N number of units, you are going to assign capital N integers to each and every unit, and j is actually depending on the size. So, that is not necessarily an integer number, right. So, now you have to choose these two numbers I and j. Now, if j is less than or equal to capital Xi, then the ith unit is selected, otherwise not, otherwise rejected, and another pair of random number is chosen. What you have to keep in mind here, please try to see the position of I and j in this statement. The rule is you are trying to choose two numbers I and j, and then you are saying that if j is less than or equal to xi, then the ith unit, not xi, but this ith unit, that is selected, otherwise not. And then means if you want to have a sample of size n, so you have to keep on drawing such pairs of number till you get a sample of size small n, right. So, this procedure will be repeated till you get a sample of the required size, say small n. Now, before I try to take an example to illustrate you how these things are going to work, let me try to first show you that how this method ensures that the probabilities of the selection of unit are varying and they are proportional to the size. Now, if you try to see in the Lahiri's method, the probability of selection of ith unit at a trial, this depends on following two possible outcomes, that either the ith unit is selected at the first draw, or it is selected in the second or any subsequent draws preceded by the ineffective draws, right. Because as long as your draws are not going to effective, you are going to keep on taking more pairs of random numbers. That is what I am trying to say, and as soon as you complete the nth unit in the sample, you will stop. Now we want to compute this probability. So, obviously, now you see these probabilities are not going to be something like one which are depending on only on I or j, but they are depending on each other. So, this type of probability that the unit is selected either at the first draw or is selected in the any of the subsequent draws. I am sure that you have done this type of problems in your probability theory courses also, right. So, such a probability can be obtained by probability that I is lying between 1 and capital N, because this is how you have chosen it, and then the probability that j lies between 1 and m given I. Once you have chosen I, then means you have to depend on you have to compute the probability of j between 1 and capital M. Now, what is the probability of drawing a number between 1 to capital N? This is simply 1 upon n, and this is written here. And what will be the probability that j lies between 1 and m given I? This is simply going to be xi upon capital M, right. You have done this type of exercise just now in the earlier case. So, now in case if I try to compute the probability that no unit is selected at a trial, then what will happen? This will be something like this, that in the first trial the probability will become 1 upon n from here. So, since this is the probability of selection, so the probability of not selection will become 1 minus xi upon m. And now, this is valid for x1, x2 up to x capital N. So, the total probability will become here I goes from 1 to capital N. So, that is what I am trying to write here, that the probability that no unit is selected at a trial is like this. So, now this can be simplified. If you try to take this summation sign inside, this will become 1 upon n, then summation I goes from 1 to capital N 1 minus summation xi upon here m. So, this will become here 1 upon capital N, 1 plus 1 up to capital N time, that is capital N, and this is something n times x bar upon m. So, this I am writing here, and if you try to take this capital N inside, this will get cancelled out, and you will get here only 1 minus x bar upon m. And now, let us try to denote it by say here q, right. Okay. Now, we try to compute the probability that unit I is selected at a given draw. Now, you see how this unit will be selected. It will be selected in the first draw. It will be selected in the second draw, provided it was not selected in the first draw. Then, in case it is not selected in the first draw, not selected in the second draw, then it is selected in the third draw. That means, the unit will get selected in the third draw, provided it was not selected in the first and second draw, and so on. So, how to find out such a probability? Where all the events, means all the previous events, previous draws, they are resulting only in the non-selection of the ith unit. So, you already have found this probability, a probability that no unit is selected at a trial is qi, right. So, now I can write down here, the probability of selection is suppose pi star, then this will become pi star, and then q into pi star plus q, it is actually q into pi star, and so on, right. So, now you can see this is the geometric progression, these are probabilities between 0 and 1. So, the sum of them is pi star upon 1 minus q. And now, in case if you try to write down this probabilities, mean the value of pi star and q. So, pi star here is xi upon nm, and 1 minus q that you have obtained is x bar upon m. So, if you try to see here, this becomes here xi upon an x bar, and then n x bar is simply your here x total, mean the population total, right. So, which is a fixed quantity, no issues, no problem. So, now this becomes proportional to capital Xi. So, thus we can see here that the probability of selection of the unit I is proportional to the size Xi. So, this method, this Lahiri method also generates a PPS sample, right. Okay. Now, what are the advantages of this Lahiri's method? Number one, it does not require writing down all cumulative totals for each of the unit, right. You do not have to write as you used to do it in the case of cumulative total method, right. The sizes of all the units need not be known beforehand, right. In the cumulative total, you must have the values of capital X1, capital X2, capital Xn, but that is not needed in Lahiri's method. What we need is that we only need some numbers which are greater than the maximum size and the size of those units which are selected by the choice of the first set of the random numbers 1 to capital N for drawing the sample under such a scheme. That is all, right. Right. Lahiri method has that it also results in the wastage of time and efforts if the unit gets rejected. But why? Because you see, you are trying to draw a pair of random numbers, then you are trying to check, and if the unit does not get selected, you have to draw one more number, and you have to keep on doing this process unless and until you get a sample of size small n, or I will say that you select a small n number of units in your sample. So, in such cases what happens that many of the draws of random numbers become ineffective. That means they are unable to provide us the sampling unit to be included in the sample. So, a draw is actually ineffective if one of the ineffective random number is selected, right. So, now let me try to take an example, and I will try to illustrate how are you going to implement the cumulative total method and Lahiri's method to select the random sample. Okay. So, first actually you can see here what is happening. We have here certain factories, and then we have the number of workers in the factory and their industrial production, right. So, that is what I am trying to write down here, that we have got here a data set where the number of workers in the 10 factories and their outputs, they are reported, right. And now we have to select the units using the cumulative total method first, and after that I will come to Lahiri's method. So, you can see here this is the factory number from factory number 1, 2, 3, 4 up to here 10, and these are the number of workers, and this is the industrial production of the factory. So, the factory number 1 has 2000 workers, for example, this number is in thousands, and then the production of the factory is 30 metric tons. Similarly, the factory number 2 has got 5000 workers and its production is 60 metric tons. So, you can see means the industrial production depends on the number of workers which are working in the factory, right. So, that is why I have taken this number of workers as my x size. So, this is my here size, and my study variable here is y, the variable which we want to study or we want to find out the population mean, this is my here y. So, you can now see here I am trying to find out the cumulative total. So, remember one thing, you have to find the cumulative total on x. So, you can see here first unit here is 2. So, this T1 becomes 2, the second unit here is 5. So, the T2, that is the second cumulative total, become 2 plus 5, and similarly the third unit here is 10. So, the third cumulative total T3 becomes 2 plus 5 plus 10 is equal to 17, and so on. So, you can see here this is how I have find the T4, T5, T6, T7, T8, T9, and T10 is finally the sum of all the units. Take the sum of this 2, 5, 10, 4, 7 and so on up to here 6. So, this is your here T10, and corresponding to each of this xi you have here yi. So, this is your here x1, this is y1, this is x2, this is y2, this is x3, this is y3, and this is here x10, and this is here y10, and so on. Now we try to implement the cumulative total method. So, first what we have to do, you can see here this T10 is equal to 64, right. So, now what I have to do here, since T10 is equal to 64, so I have to draw a random number r between 1 and 64. And suppose I draw the random number, and suppose it's suppose r turns out to be 23. Now, you have to see where this 23 is lying. So, we come back to our this here total, this is the fourth column. So, you can see here your number is 23, 23 is lying somewhere here. So, this is between T4 and T5, right. So, this 23 is lying between T4 and T5. So, what will happen? This fifth unit, this is T5, this fifth unit will be selected. Now, the question is, fifth unit means what? X5 or Y5? Y5, Y5 will be selected. And now, whatever is the value of y5, that we have to see. So, this is your here y4 and this is here y5, y5 is equal to 8. So, now this y5 equal to 8 enters in the sample, and the first sampling unit becomes y5 equal to 8. Now, Suppose we come to second draw, and once again we try to draw a number, say r between here 1 and 64. Suppose this number comes out to be 38, that is r is equal to 38. Now you have to see where this 38 is lying in the fourth column of this table. You can see here, if you try to come here, you will see here somewhere here 38 will be somewhere here between, because T7 is 33 and T8 is 47, right. So now what will happen, that 38 is lying between T7 and T8. So the 8th unit will be selected. Now 8th unit means what, X8 or Y8? Y8, because X was used only to help in the selection of Y. So now whatever is the value of Y corresponding to X equal to 8, that is X8, that will become the part of the sample. So let us try to see what is your here Y8. So Y6 is 13, Y7 is 4 and Y8 here is 17. So corresponding to this X8 equal to 14, this Y8 equal to 17 enters in my sample. So now I have obtained two sampling units, 8 and 17. Now similarly means you can keep on doing it, and this procedure will be repeated again and again till the sample of required size is obtained, right. Suppose if you want to draw a sample of size 20, so that means you just have to draw 20 numbers between 1 and 64, that is all. And just try to use this rule that try to look into the column of this cumulative totals, and then just follow the rule and get the value of Y. Here I would like to have your attention that many times people get confused that with this cumulative total and Lahiri's method, what are we trying to collect? Because there are two variables, X and Y, and the confusion comes because if you try to think in terms of ratio or regression method of estimation, there also we had X and Y, and but whenever we were trying to draw the sample, the sample observation were actually paired observation, Xi, Yi. So sometime keeping that thing in mind, because we have just completed the ratio and regression method of estimation, many students get confused. But my request is this, please close the chapter ratio and regression method of estimation now. This Y and X here in the PPS, they are different things, right. And once I say that we have to select a sample, we have to select a sample on the steady variable Y. So the observation will look like Y1, Y2, Yn, not like X1, X2, Xn. But definitely when we will try to transform the variable, then corresponding to each Y1, Y2, Yn, we will use the size X1, X2, Xn to modify our random variable, right. So in this case also, when I am trying to select the sample will be something like Y1, Y2, this Y20. That you have to keep in mind, okay, right. Now I come to the Lahiri's method. You just have a quick look, quick revision in the Lahiri's method so that you can use it very easily. What was this Lahiri's method? That first you have to select a pair of random variables I and j, and they have to be selected in such a way such that I is lying between 1 and n. Now you can see in this example, capital N is here 10 or 64, 10, and j is what you are here, that we have to find out that whatever is the maximum size among all those x1, x2, x10, right. And then once I choose this pair of I and j, then I have to check this condition j less than or equal to xi, right. So, now we try to come to a slide and try to implement it the Lahiri method. So, you can see here I have just copied the same table once again, so that I can execute the methodology of Lahiri's method here, right. So, now if you try to see, now you have just relooked into the rule. So, you need here two numbers, say I and j. So, I was between 1 and capital N and j was between 1 and say m, and m is your here maximum of xi. So, now what is your here n? If you try to see here in this table, you have here all together 10 numbers. So, this is what we had discussed, that we need to associate one integer with every unit. So, we have got here 10 factories. So, every factory number has been associated one integer 1 to 10. So, this now I will be lying between 1 to 10, right. And what is here m? M is going to be the maximum value among this size. So, now in case if you try to look into this data over here, this is 2, 5, 10, 4, 7, 12, 3, 14, 11, 6. So, 14 is the maximum. The maximum value of the size among the values x1, x2, x10, x8 equal to 14 is giving us the maximum value. So, now I can say here m is going to be here 14, which is actually here x8, right. So, now I need to draw here two random numbers, a pair of actually random numbers, such that I is lying between 1 and 10 and j is lying between 1 and 14. Well, I have to clarify here one thing, that I am using the word here pair of random numbers, right. Pair of random numbers means you have to draw two numbers, but then you have to draw them one by one. First you try to draw a number between 1 and 10, and then you try to draw one more number between 1 and 14. Yeah, don't get confused that you have to simultaneously draw both the numbers. You have to draw it one by one, but they should be in the pair. Now, we try to look an example and to show you that how are we really going to draw the random sample using this Lahiri's method, right. So, remember one thing, that you have to draw two numbers I and j, and you have to check the condition whether j is less than xi or not, right. So, you can see here that in the first column here, I can draw the columns here if you wish, just for the sake of clarity, say like this 1, 2, 3 and here 4, right. So, you can see here that in the first column I am trying to draw here a number I between 1 and 10, in the second column I am trying to draw here a number j between 1 and 14, and then in the I am going to check the condition j is less than xi or not, and based on it I am trying to, then we will take a call whether the number has been accepted or not. So, suppose I draw a number between 1 and 10 using the random number table, and suppose this number comes out to be I equal to 3. Then I draw one more random number using the random number table, and this comes out to be suppose 7. So, this is the value of here j equal to 7. Now, you have to see this condition j is less than xi. So, if I write it very clearly, so j is equal to 7, and what is here xi? Xi here is actually x3, xi equal to 3, and this value you can see this is actually here 10. So, now you have to see whether 7 is 10 or not. Whether there is 7 is less than 10 or not. So, you can see here that 7 is less than 10, yes. So, this trial is accepted, and then which unit enters into your sample? This is yi, and here I is equal to 3. So, yi equal to 3, that is y3 unit will come into your sample. So, here I can write down here my sample will keep on containing y3, that is the first unit which enters here. Then I try to draw one more pair of random number, and suppose I comes out to be here 8 between 1 and 10 and j comes out to be here 13 between 1 and 14. And then if you try to see this condition, j is less than xi, so j equal to here 13 and xi here is x8 whose value here is 14. So you can see here that 13 is less than 14, this is correct. So this trial is accepted, and the corresponding value of y I equal to 8, that is y8 enters into my sample. So I can add here one more observation y8. So now I have got a sample of size 2 and both my trials have been accepted. Now I try to draw one more pair of number, and it comes out to be I equal to 4 and j equal to 7. So you can see here now j equal to here 7 and xi x4, this value is here 4. So now you have to see what is happening here. Is this j greater than xi satisfied? No. So this trial is rejected, and this pair of numbers does not give you anything. And similarly, if you try to take here I equal to 2 and j equal to 9, you will see here that j equal to 9 and x2 whose value is here 5, is this condition true? So this trial is also rejected. And then again finally I tried one more observation I equal to 9 and j equal to 2. So you can see here j is equal to 2 is less than equal to x9 whose value is 11, and this is correct. So this trial is accepted. So now I will say here y9 is accepted, right. So you can see here that here you have drawn total 5 observations, and out of those 5 observations 3 are accepted and 2 are rejected. So this is what I mean that what is the effective draws and non-effective draws. So all those draws where I have accepted these 3 numbers, they are actually called effective draws. And this is what I actually meant when we discussed the drawback of this Larry's method, that all the numbers are not really going to be accepted. For example, if you try to see out of this file 5 random numbers, 3 are only accepted and 2 are getting rejected. So that was the drawback, and if you have to take a large number of samples, then yeah, that will require some more time to draw such pairs of number, and if they are not getting accepted, that will result in the wastage of time, right. So but this is how you can see that we can draw the random numbers in PPS WR using the this cumulative total method and Larry's method, right. Okay, so now we try to end this lecture. So you can see that in this lecture I have discussed that how one can collect the random samples in this PPS WR. And one thing we have to keep in mind that when we are trying to go for PPS WR, then there is no problem, but in the case of PPS WOR, you will have to redistribute the probabilities of selection each and every time. And you can see that in these 2 examples, how this xi, which is the size of the unit, is playing the role. You can see that this is playing a very important role in choosing the value of y. Depending on the value of x, we are going to choose the value of yi. And this is how the probability of selection of unit depends on the size, and that is why we say that it is PPS, because I have shown you theoretically that both these methods are going to yield the observations which are in which the probability of selection of unit is proportional to the size. So I will request you that you try to take a couple of more such examples from the book, and or even if you wish, you can choose any pair of random numbers from the random number table and try to see that how can you execute it, right. So you practice it, and I will see you in the next lecture. Till then, goodbye.